Hello everybody, this is again Dr. Sergey Sargasov, and today we will look into using algebra, using algebra, and then also using calculus, another way, right, to find minimum or maximum locations, of a parabola, a quadratic function, So this is really cool. Watch this. Let's see how this is done. Let's put a few lines here just to make it look kind of nice for the title. There's this. And then let me kind of do the copy paste. There's this. Okay, so let's do this. Ready? Let's have some fun. Let me show you what I'm talking about. Let's make up a function. Let's make up a function and let's look at it in an algebraic sense. I think algebra is a more insightful way. Forget that calculus. We can do this. Watch. Let me show you. We've done this in algebra. We call it vertex form. Let's say we're told find the minimum, because let's say the parabola is going up, Find the minimum, of the function f of x, is equal to, let's just do kind of a, nothing, just 1x squared. So x squared, let's do, let's maybe do plus an x minus a 6, And let's see what happens here, right? And some people may struggle with this because it's a 1x, right? But we can do this. So find a minimum of this function. Let's do this with algebra. Okay, so to do this, you can find, like, let's say we're graphing the thing, right? You're thinking, well, I'm going to graph this. Let me find the y-intercepts. What is that? That's when x is 0, and what's going to happen is f of 0 is going to be a negative 6, right? And so I'm kind of verbally doing some of these things, and you can see why, because f of 0 is equal to 0 squared plus a 0 minus a 6 is equal to negative 6. So I'm trying to graph it, trying to understand its graph, understand the graph, algebraically, algebraically, that's what we're trying to do. So, and then maybe x-intercepts, what do we do with that? If, again, this is optional, but if you wanted to find x-intercepts, right, if you want to make a neat graph of this, you can say, you know what, this is when y equals 0, and you're going to set f of x equals y equals 0, so 0 is equal to x squared plus an x minus 6. We've solved this as a standard form quadratic equation. We can actually factor this. 0 is equal to what? X plus a 3 times an x minus a 2, right, if we factor it correctly. You see that? And then what happens? By the zero product property, one of these is 0, right? Something times something is 0, one of them has to be 0. So x is plus 3 is 0, or what? X minus 2 is 0. And meaning that we have x is equal to negative 3, or x is equal to 2. So with that, we have actually the x-intercepts, right? Which are basically the negative 3 comma 0 and the 2 comma 0, right? So we have some points, The points are 0, negative 6, negative 3, 0, and 2, 0. And those are nice points to have, And now the main thing is, what is that vertex, right? And the vertex, we're going to do this. We're going to complete the square. So we're going to say, you know what? F of x, which is equal to x squared plus an x minus a 6, right? We'll group together the terms x and x squared terms, right? And we'll say, you know what? It's going to be x plus half of the 1 is a 1/2, squared. Because if you square it out, you're going to get x squared plus a 1/2 x plus a 1/2 x, giving you back this 1x, But at the very end of it, you'll have a plus a 1/4. So get rid of it, minus a 1/4. And now it's equal. This underlined, single underlined, is equal to this single underlined, And the minus 6, it remains, so minus 6. But now it looks a little different. This is called completing the square. And so let me show you. This is from here to there. I'm going to do it again. This is called complete the square. Procedure. And this is why, see, now we have a complete square. We don't have a squared in the linear term. We just have one thing squared. And even though it looks kind of messier on the right side, it's going to be much more helpful to figure out the maximum minimum. So finally, this is equal to what? Equals to x plus a 1/2 squared, and combine the terms, a negative 1/4 minus a 6 is minus a 24 over 4, ultimately a minus 25 over 4 if you put together right? This is a negative 6 1/4 or negative 25/4, okay? And so now, what does this tell us? The vertex of this parabola is where? Negative 1/2, right? That's what makes that 0, x squared of 0, right? And negative 25/4, okay? And remember, the vertex form of a parabola, if you forgot what the vertex form is of a parabola, let's look at that. That's in general f of x, the quadratic function f of x is equal to ax minus h squared, right, plus a k. And if you have it in this form, where a is 1 for us, right, depends. If a is bigger than 0, we have it going up, and we have a minimum, right, right there at the vertex. At vertex, which is going to be always hk, okay? And if a is less than 0, this is just some kind of, theory here, less than 0, you're going down, parabola's down, it was flipped by the transform of negative, right, negating it, and so you would have a maximum right here, maximum right there, at also vertex, what? Vertex again, hk, okay? And some people ask me, why is that the vertex? And let me tell you why. Look at here, for example, this specific example here, okay? I'm adding a something squared, x plus 1/2 squared, with real numbers, it's a positive number, unless it's 0, right? So you're adding something, you see, something positive, or, at least it's not negative, to a negative 25/4. So you're negative 25/4, or you're going up from it, up, 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 up. The only way you're going to get exactly this small number is if you're just going to add 0 to it. And the only way to add 0 to it is if x is a negative 1/2, okay? And when you do have a negative 1/2, you're adding a 0, and you're going to get negative 25/4, the smallest, the lowest point on this graph. Let's graph it to see what's going on, okay? That's nice to always see what in the world does our graph even look like. Okay? So let's do a neat graph here. And we have, remember, x-intercept something negative, what was it? A negative 3 and a 2, and it's going left a little bit. So look at this. Let's do this. This is like a negative 1, negative 2, negative, kind of extend a little bit, negative 3. You see what I'm doing? I'm kind of stretching it out horizontally a little bit. And this is a 1. This is a 2. We have these x-intercepts here and here, right? Negative 1, negative 2, negative 3. That's just a 1. And let's do this. This is 1, 2, okay, 3. Let's kind of squish it out a little bit vertically. So 4, squish it, 5, okay. And this is a negative 1, negative 2. So I'm labeling it a little bit. I just want to show you like a little bit of the graphing. Now we have a vertex negative 1/2, negative 6 1/4, right? Where's that? That's going to go down, down, down a little bit more for the vertex. So negative 1/2, here's the axis of symmetry, x equals negative 1/2. And you go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and a little bit more right over here, negative 6 1/4, okay? But it's not there, it's right here, right? So that's our vertex, which is negative 1/2 comma negative 25/4, okay? We have the y-intercept was, I believe, a negative 6, right? 0, negative 6, okay, so there it is. And so we have, look what we have. We have this, let me kind of be careful with the graph, but it looks like this, okay? It looks like this. Parabola to the right going this way, yeah? And it's going on and on and on. See, getting steeper and steeper and steeper on its way up to the right, and then to the left, it's going to go left, 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 left. It's really hard to keep it smooth here on the way I'm drawing it, but let's see. It's going to go something like that, okay? And there is our parabola. It's not bad, right? It's not too bad. So there's our parabola, and it's looking something like that. And there is our minimum, okay? Right there. So it's a lot of work. Again, all you have to do is just find the vertex of it, put a vertex form. So all you have to do is this thing step in orange. And all of a sudden, the minimum is negative 25/4. That is the answer, right? So minimum, and that's, that's not so bad if you know what you're doing. Minimum value is negative 25/4. And it happens when x is equal to what? To negative 1/2, okay? And we're done. Da, 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 da. Algebraically. Calculus, well, calculus is different. Using calculus. Using calculus, ready? Calculus, and I mean the basic calculus of derivatives, okay? Derivatives and extreme value theorem, right? Or the derivatives and just figuring it out, like if it's a critical number, right? are we going to have a, the first derivative test is going to be, or even the second derivative test, is it going to be maximum, minimum at that location, or neither? Derivatives and derivative tests, right? Okay, so let's see, okay. F of x is equal to, and we already know the graph of it kind of by looking up there, but let's say we didn't. Well, x squared, and then what, plus or minus, it's plus an x minus a 6, right? What's the derivative of this? Okay, what's derivative? Derivative is, I'm just going to pretend we know derivatives. X squared goes to 2x, plus a x goes to plus a 1, minus a 0 for 6, right? Okay, so let's figure out where in the world is it equal to 0. It's equal to 0 when what? When x is a negative 1/2. Oh, okay, cool. All right, and so we have already x is negative 1/2, and now is a minimum or maximum, right? So that's f of a negative 1/2. We'll find it, plug it in, and we get, look, we should get a negative 25/4, but let's see. We get negative 1/2 squared is a 1/4, minus a 1/2, right? Minus a 6, it's a negative 1/4 minus 6, and that's equal to negative 25/4, okay? Now, max or min, all right? Let's do the first derivative test, right? So there are two options here. So first derivative test, by first derivative test, if you remember what that is, let me show you what it is if you forgot. Derivative test, you kind of construct a number line, okay? It's like a inequality when you solve inequalities, okay? And you're wondering, when is the derivative positive and when is it negative? So 2x plus 1, which is the derivative, right? When is it bigger than 0? Well, it's 0 at negative 1/2, right? Now, if it's to the right of negative 1/2, it's positive, right? Because you're adding a number bigger than, negative 1 to a 1 when you multiply by 2 to negative 1/2. So anyway, or the number here, right? Or if you try a number like a negative 10, right here somewhere, and you 2 times it plus a 1, you're going to be a negative. So this is all negative, 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 and then here we go positive, 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 positive. Let's say even a 0 here, right? Put a 0 in, 2 times 0 plus 1 is a positive 1. Okay? So this means, if negative derivative means you're decreasing, remember? Decreasing. And then you're increasing. And so if you're decreasing, okay, and then you're increasing, what does that mean right here? This has to be a local, okay? It's going to be extreme also, but local minimum, okay? Because it's going down and then up. Minimum, okay? And so that is the big thing that, yeah, we have the minimum at what? Negative 1/2, negative 25/4, and so that answer would have been a negative 25/4 at the negative 1/2. But let's try the second derivative test. By the second derivative test, okay, let's do the last thing, derivative test, okay? What can we do here? Well, let's forget the number line and let's forget the, the first derivative test. Let's say you're like, hey, you know what? So I know f of x is equal to, what is that, x squared plus x minus 6, and then you can quickly find the derivative, which is a 2x plus 1. See, as a calculus student, you would do this and you would not even remember or maybe know the algebraic way of solving it. That's why I'm showing you this video, okay? That it's so beautiful to do it, I think, all of this, there's just this way, this little orange, these 2-3 lines, the vertex form of a parabola. That is the maximum minimum of a quadratic function. Yes, it's difficult more so with polynomials of degree higher up. Then you need calculus. Is definitely essential in many ways there. But let's see, let's do another derivative. So second derivative will be just a 2, okay? Now we care about what about the 2? That it's bigger than a 0, right? And that means it's concave up. It's the shape of a kind of upward parabola. Concave up. And if it's concave up, and so that and actually everywhere, right? So that even like f double prime of the negative 1/2, right? Because we had the critical number Cn was here, from this was x is equal to negative 1/2. It's still bigger than 0, right? It's equal to 2, bigger than 0, and so it's concave up there, meaning that it has to be a minimum. So minimum, okay, right there, at, right, not maximum, but minimum. So we were wondering, hey, is it a maximum or minimum? It's a minimum at x equals negative 1/2, which n is, and equals, we compute it, right, f of negative 1/2 is equal to the negative 25/4. Da-da-da-da-da-da-da. And we're done, okay? Regardless of which way you do it, you get the right answer. You have to be careful. But just remember, there's an algebraic component to solving this minimum maximum of a quadratic function. Okay? Thank you for watching. Hope this was entertaining and insightful.